Bismillahirrahmanirrahim. Assalamu alaikum, ladies and gentlemen. Hope you are all fine. My name is Hafiz Mohsin Rasool and ID number is F2018-070-025. Our course code is MA218 and course title is Ordinary Differential Equation Section M, submitted to Dr. Bamanzur. I am studying UMT semester 4. Now we will present here our presentation. Our presentation topic is Laplace transformation of trigonometric function. So first of all, we will discuss about Laplace transform introduced by Pierre-Simon Laplace. It is a French Newton began work in calculus which led to the Laplace transform. One of the first scientists to suggest the existence of the black hole. In short, Laplace transform introduced in Pierre-Simon Laplace, scientist. Okay. Now we will discuss about history of the Laplace transform. History of Laplace transform is a mathematics, a particular integral transform invented by the French mathematician Pierre-Simon Laplace and systematically developed in the British physicist Oliver Heaviside to simplify the solution of the many differential equations that describe physical process. It became popular after World War II and today it is most useful for electrical engineering in the solution of various electronic circuit problems. And Euler began looking at integral solution to differential equation in the mid 17th century. Z is equal to integral x multiplied into x into exponential function of ax. Zx is equal to a integral x to infinity EAT x into t and dt. Lagrange took this as a step while working on a probability density function and took a look at the form of the following equation. Look like Laplace transformation. And finally in 1785 Laplace began using a transformation to solve equation to the finite difference which eventually lead to the current transform. In short, in history 17th century 1744 to 1785 working on that Laplace and integral and derivation and other properties of Laplace. Then introduced in Laplace in life in 1785. Now we will discuss about what is Laplace transform. Let f be the function whose domain include 0 to infinity, that the Laplace transform of ft. First of all, I will discuss Laplace transform with respect to ft. Laplace ft into s is equal to infinity over infinity to 0 ft multiplied e to power minus st derivative with respect to t. It is another function whose variable is usually denoted as s. And also note that Laplace transform involves a improper integral. It is a linear operator. It is also a form of an integral transform. Stylish L is denoted by the Laplace symbol. So it is called a Laplace transform. So basically we are seeing another definition of Laplace transform is we will interested in single defined for t greater than equal to 0. The Laplace transform of a single function of the function is defined by fs is equal to infinity to 0 ft multiply e to power minus st dt. F is a complex value function of a complex number. S is called a complex frequency with unit second inverse. For those S belong to C for which the integral makes sense, T is called Time variable in second real st is unitless. For now we assume f contain no impulse at t is equal to 0. It Laplace transform convert ft to fs, where is integrated and s is t is integrated and s is a variable. So it's called a Laplace transform in differential equation at real life. So first of all, Laplace transform with respect of derivative. Its general mathematical form is L first derivative of t is equal to sfs minus f0, and second derivative of Laplace with respect to t is s square fs into fs minus s into f minus f double first derivative to 0. It is a derivative of Laplace transform. It's look like a series upside continue. So last step is LF f derivative f power n into t is equal to Sn into fs minus Sn minus 1 into f0 minus s power minus n minus 2 f first derivative to 0 minus Sn minus 3 up so on. Now we will discuss about Laplace transform of integral. Let g be the running integral of a signal f is gt is equal to integral t into 0 ft dt. Then gs is equal to 1 over s into fs. Time domain integral become division by frequency variable for the general integral. Now integral gt into dt with the respect of t is equal to 0. It is a value of integral when t is equal to 0. So its basic formula will derive as Lagrange into Lagrange curly bracket integration gt with respect to t is equal to gs over s plus 1 over s into gt integral gt with respect to t, and t is equal to 0. T is replaced by time. Now we will discuss about why we use Laplace transform in differential equation of the and real world and real life. Find solution to differential equation using algebra. Useful with multiple process and system. No need for convolution of input and differential equation solution. It means Laplace transform are used in many things in real life like circuit, mechanics, electrical engineering, etc. How to use Laplace transform? The Laplace transform can be used by differential equation to fourth step. So given as take the Laplace transform differential equation using the derivative property as and other properties as necessary. Put initial condition into the resulting equation. Solve for the output variable. Get result from Laplace transform table. If the result is in a form that is not in the table, you will need to use the inverse Laplace transform. So this pattern are used in how to use Laplace transform. Now we will discuss about example of a Laplace transform with exponential form function. Ft is equal to e power infinity into t. So first step is applying Laplace on both sides. So Laplace definition applying. So result is integral infinity into 0 e power minus st into e infinity t dt. And next step we will common t e power minus into s minus t with respect dt. Second step is applying integral with limit. Limit b approaches to infinity, integral infinity to 0 e power minus into s minus t dt. So next step is limit b approaches to infinity e power minus s minus into infinity t and s minus over s minus t into b into 0. So in this step, putting the value of t, first of all we will put t is equal to b, and then we will put t is equal to 0. So result is e की power minus s minus infinity into infinity over s minus infinity plus 1 over s minus infinity. So final e की power minus infinity s minus infinity plus 1 over s minus infinity. So this portion is 0 plus 1 over s minus infinity is equal to, whole answer is 1 over s minus infinity. If we will let Lagrange e की power minus infinity, then our result is 1 over s plus infinity. Now we will discuss about Laplace transform of trigonometric function. Trigonometric function are basically like cos, tan, secant, cot, etc. Now first of all we will discuss about Laplace transform of sine. Let sine denotes the real sine function. Let LF denoted by the Laplace transform for a real function. So Laplace transform of sine formula is equal to Lagrange into sin at is equal to a over s square plus a square. When a belongs to real number greater than 0, constant r exponential into s greater than a. So its proof is L sin at into s is equal to applying Laplace definition, infinity to 0 e to power minus st sin at dt. So next step is limit L approaches to infinity, integral L into infinity e minus s t sin at dt. So next step is applying integral e to power minus sl minus s sin al minus a cos al over x square plus a square minus e to power minus s multiplied by 0 into minus s 0 multiplied by a minus a cos into 0 multiplied by a over s square plus a square. S square plus a square is LCM. So roof step is x sin 0 plus a 0. So final result is a over s square plus a square. And now we will discuss about Laplace transform of sine. Let sine denote the real sine function. It is a Laplace transform of a real function. Its formula is s over s square plus a square, where a belongs to real number greater than 0, constant r into s greater than 0. Now applying the Laplace, then applying the integral. So fourth step is applying integral limits s cos 0 multiplied by a minus a sin 0 into a over s square plus a square minus e की power minus sl into minus s cos al minus a sin al into x square plus a square. So we will discuss about simplify. Cos 0 is equal to 1, sin 0 is equal to 0. So above, so roof s over, so final result is s over x square plus a square. And sin over cos is equal to tan theta. If we need to find the Laplace of transform of tan theta, so this formula apply to get the output of Laplace transform of t. Sin theta is equal to 1 over cosecant theta is equal to 1 over sin theta, cot theta is equal to 1 over tan theta, secant theta is secant theta is equal to 1 over cos theta. Now we will discuss about application of Laplace transform. Application of Laplace transform in real life to applying in circuit equation, in circuit like physics, chemistry, houses, etc. There are two related approaches: derive the circuit differential equation in time domain and transform from ODE to S domain. First of all is time domain and second is S domain. Transform the circuit of S domain to derive the circuit equation of S domain using the concept of impedance. We will use to the first approach. We will derive the system equation in the T plane, the transform the equation to S plane. In short, T plane and S plane we will discuss in this application. How can use Laplace transform of this equation, this application in Laplace transform. So consider the circuit when with the close at t is equal to 0, v is equal to 0. Solve the current it in the circuit. Substituting in the circuit 1 over c into I dt plus r is equal to v, we obtain here c is equal to 10 to the power minus 6, r is equal to 10 to the power 3, v is equal to, for all value put in equation, 1 over 10 to the power minus 6 I dt plus 10 to the power 3 I is equal to 5. Multiplying on both sides by 10 to the power 6. So result is, and then next step is taking Laplace transform of both sides to find the value at t is equal to 0. v is equal to 1 over c integral I dt. Putting these together give all this value is equal to 1, and this value also is equal to the 10 to the power minus 6 is also equal to the q naught. It is the initial charge. Returning to our problem and substituting 1 over s plus 10 to the power minus 6 s plus 10 to the power minus 3 I is equal to 5 multiplied by 10 to the power minus 6 over s. Collecting term of subtracting 10 to the power minus 6 from both sides. So final result is 4 multiplied by 10 to the power minus 6 over s, multiplying through out by s. So final result is 4 multiplied by 10 to the power minus 6. Solve for I is equal to 4 multiplied by 10 to the power minus 6 over 1 multiplied by 10 to the power minus 3. So the final result is I is equal to 4 multiplied by 10 to the power minus 3 e to the power minus 1000 t by applying the inverse Laplace transform given circuit at time t. So these are the example of application of Laplace transform in circuit equation. Hence proof, and thank you. Allah Hafiz.